From a regular octagon, a triangle is formed by connecting three randomly chosen vertices of the octagon. What is the probability that at least one of the sides of the triangle is also a side of the octagon? So a case when a side of the triangle is not going to be a side of the octagon is when the vertices are not adjacent to one another. So what I mean by that is this vertex and this vertex are adjacent. So if we pick this one that's not adjacent and then another that's not adjacent to both, like this vertex, connect them like this, we see that the sides of this triangle, none of them is a side of the octagon. However, if we chose two vertices that were next to each other, the triangle would be a side of, that side of the triangle would be a side of the octagon. So if we label these, there are 8 vertices labeled out 1, 2, 3, 4. So the number of possible triangles we can make are, since there are 8 vertices, just choose 3 of them. And this comes out to 56 triangles that you can possibly make. I want to focus in on the triangles that will not be a side of the octagon. So those types of triangles, let's just think about the ones where it's just going to have one is going to be one of the vertices. So it always has to be true that vertices are not next to each other. So we could do 1 and 3 are not next to each other, and then 5 is not next to either. And keep going with this. 1, 3, 6 is going to be true. 1, 3, 7. Couldn't do 1, 3, 8 because 1 and 8 are next to each other. Then go with the 4s, 4, 6. And so these are all the combinations that have a 1 in it. I can't do any more combinations with a 1 in it without vertices being adjacent to each other. Now we'll start with 2s. We can start with 2, 4, 6. 4, 7. All right, and these are all the ones with 2s. So there's 6 with 1s, all 1s, 6 with 2s that you can possibly do. And now we're going to do the remaining 3s. There are still more with 3s we could do. We could do 3, 5, 7, because that doesn't have a 1 in it. Could do 3, 5, 8. And could do 3, 6, 8. So there are 3 of these. And then the last one, the remaining that we can do with a 4 is 4, 6, 8. And there's 1 of these. And that's it. If we did a 5, then you'd have to do 5, 7, and then 1, which we already have written here. So everyone with a 5 is already accounted for. So there are a total of 16 combinations here. So 16 out of the 56 are going to be triangles where the side is not part of the octagon. So therefore that means that 56 minus 16, the remaining ways in which you can make a triangle is going to have a side of the octagon. So 56 minus 16 is going to be 40. So the ratio we're looking for is they're going to be 40, 56, and that is equivalent to, divide this by 8, and this is going to be 5 over 7. So you have a 5/7 probability where at least one of the sides of the triangle is going to be a side of the octagon. So the answer is choice D.